Test each of the following equations for exactness and solve the equation. The equations that are not exact may, of course, be solved by methods discussed in the preceding sections. Hello everyone! Before we start to solve the given problem, let me introduce the exact differential equation. The meaning of exact differential equation is a differential equation is said to be exact if satisfy partial derivatives of n with respect to y must be equal to partial derivatives of n with respect to x. All we know that the partial derivatives of n is associated with dx, while the partial derivatives of n is associated with the dy. To solve for the exact differential equation, we need to use the following formulas. We have the partial derivatives of f with respect to x is equals to m function of x and y, and partial derivatives of f with respect to y is equals to n function of x and y, where f is the solution to an exact differential equation. The given problem is w cubed plus wz squared minus z dw plus z cubed plus w squared z minus w dz is equals to 0. This is our m and this is our n. In order for us to get the exactness of a differential equation, let us have the partial derivatives of m with respect to z is equals to partial derivatives of n with respect to w. And now let us have to solve the partial derivatives of m with respect to z is equals to d all over dz times w cubed plus wz squared minus z. To solve the partial derivatives, let us consider the other variables with a constant. So we have the partial derivatives of w cubed is automatically 0 because it is respect to z, plus the w is considered as a constant. So let us solve this z squared. The derivatives of z squared is 2z, so we have 2wz, and the derivatives of z is 1, so we have minus 1. The partial derivatives of m with respect to z is equals to 2wz minus 1. Let us solve the partial derivatives of n with respect to w is equals to d all over dw times z cubed plus w squared z minus w. Let us consider the variables of z is constant. So we have the partial derivatives of z cubed is 0 because it is considered as a constant. We have the partial derivatives of w squared z. Let us consider the z is constant, so the derivatives of w squared is 2w, so we have plus 2wz. The derivatives of w is 1, so we have minus 1. So we have partial derivatives of n with respect to w is equals to 2wz minus 1. So the conclusion is the partial derivatives of m with respect to z must be equal to the partial derivatives of n with respect to w. It is exact. And now let us go back to the sample discussion last time. To solve for the exact differential equation, we need to use the following formulas. Let us have the partial derivatives of f with respect to x is equals to m function of x and y, and partial derivatives of f with respect to y is equals to n function of x and y. And now let us proceed to the partial derivatives of f with respect to w is equals to m function of w and z. All we know that the value of m function of w and z is we have partial derivatives of f with respect to w is equals to w cubed plus wz squared minus z. And now let us have the simplification. So we have, let us remove the dw to the left side. So in order for us to remove this, let us equate. We have partial derivatives of f with respect to w is equals to w cubed plus wz squared minus z. Let us multiply both sides by dw. So we have cancellation. So we have the partial derivatives of f is equals to w cubed plus wz squared minus z times dw. And now, in order for us to get the f is, let us have the integral both sides. So we have the integral of df is equals to integral of w cubed plus wz squared minus z dw. So we have f is equals to the integral of w cubed dw plus the integral of wz squared dw minus the integral of z dw. And now let us simplify it. We have f is equals to integral of w cubed dw plus, let us consider this as constant. So we have c squared integral of w dw minus, let us also consider this as a constant. So we have z integral of dw. We have f is equals the integral of w cubed dw is w raised to 4 all over 4 plus the integral of w dw is w squared all over 2 z squared minus the integral of dw is w z. And now let us add plus q z. Let us solve the partial derivatives of f with respect to z is equals to n function of w and z. And now we have the partial derivatives of f with respect to z is equals to the function of n. So we have the z cubed plus w squared z minus w. And now let us equate it. We have the multiply both sides by dz. So we have cancellation. So we have partial derivatives of f is equals to z cubed plus w squared z minus w dz. And now let us integrate both sides. So we have the integral of partial derivatives of f is equals to the integral of z cubed plus w squared z minus w dz. So we have f is equals to the integral of z cubed dz plus the integral of w squared z dz minus the integral of w dz. And now we have f is equals to, we have the integral of z cubed dz plus, let us consider this as a constant. So we have w squared integral of z dz minus the, let us consider this as a constant. So we have w integral of dz. And now proceed to the integration. So we have f is equals to z raised to 4 all over 4 plus the w squared. The integral of c dz is c squared all over 2 minus the integral of dz is wz. We have plus rw. Let us equate f. So cancel it, cancel it, cancel it, cancel it. So we have w raised to 4 all over 4 plus q of z is equals to z raised to 4 all over 4 plus r of w. And now the value of q of z is equals to z raised to 4 all over 4, while r of w is equals to w raised to 4 all over 4. And now let us substitute the value of q of z to this equation. So we have f is equals to w raised to 4 all over 4 plus w squared z squared all over 2 minus wz plus the value of q of z is z raised to 4 all over 4. Z raised to 4 all over 4. And now let us multiply by 4. And now we have cancel out. So we have f is equals to w raised to 4 plus the 4 divided by 2 is 2, w raised to 2, z raised to 2 minus 4 wz plus cancel out also. So we have plus z raised to 4. And now let us proceed to the next. So we have f is equals to z raised to 4 all over 4 plus w squared z squared all over 2 minus wz plus r of w. And the same to the last time. So we have f is equals to z raised to 4 all over 4 plus w squared z squared all over 2 minus wz. And now let us substitute the value of r of w. The value of r of w is w raised to 4 all over 4. So we have plus w raised to 4 all over 4 and multiply by 4. So we have f is equals to z raised to 4 plus 2w squared c squared minus 4wz plus w raised to 4. As we notice that it is also the same with this. And now, finally, we get the exact differential equation. And that's all for today. Stay safe and God bless. Thanks for watching.